afternoon, everyone. This is Syed Fasiyuddin from ISL Engineering College. Today I am going to take you the ground wave propagation, a topic of antenna and wave propagation. So today we are going to learn about what is the meaning of propagation, what are the modes of propagation. So before going to start today's class, let us take a glance of the previous class. In the previous class we have discussed about what is a ground wave propagation and what is the meaning of the propagation and how the propagation is carried out and how it is going to reach to the transmitter, to the receiver end. So all these things we have discussed. Today's class we are going to discuss about what are the modes of propagations. So let us continue with this discussion. So today we are going to discuss about modes of propagation. So in today's class we are going to discuss about this modes of propagation. So as we know that the modes of propagation depends upon the wave which are propagating near the earth surface are called ground waves. The wave which we are seeing on the ground nearer to the earth. So when we are seeing towards the earth, the wave which we are seeing towards the earth are considered to be the ground wave. And we know that on a ground wave will be having two types of waves. So ground waves we are classifying into two categories. One is for space wave and the second one is for your surface wave. So we are considering this space and surface by looking into the transmitting end and into the receiving end. By looking into the transmitter as well as receiver, we are classifying into two categories. So the wave which we travel from transmitter to the receiver directly without any reflection are called direct wave or space waves. So what we are saying, we had a transmitter at one end and will be having the receiver at one end. So the waves which travels from transmitter to the receiver directly. So the waves which directly communicating from the transmitting end to the receiving end. So these kind of wave are considered to be the direct wave, or we are saying it as space wave. And second category, surface. So what is surface means? The wave which we are propagating. Suppose you will be having transmitter and you will be having the receiver. So in this, the wave which propagates to the receiving antenna through the reflection from earth surface are called it as ground reflected waves or space waves. So the transmitter is there, then we'll be having one earth surface. We are considering it earth at the one end. From the earth crust it is traveling towards it and it is getting received from the earth. Then it is considered to be the surface wave. So in order to receive this earth surface, the waves which reaches the receiving antenna as a result of scattering and reflecting from the ionization in the upper atmosphere. So or the atmosphere is there. In this atmosphere, suppose we will be having earth over there. From the atmosphere there is a different layers are there. Ionosphere, biosphere, lithospheres, all different waves we had in this layers. So the wave which reaching the receiving antenna from this antenna is receiving as a result of scattering and reflection from the ionization in the upper atmosphere. I'll call it as sky waves. The waves which we are getting from this end. Then what is the name we are giving for that? We are saying it as it is a sky wave. The region for ionization in the sky wave is all about 80 km. That means the distance from where this sky wave is going to propagate is above the 80 km from the earth surface. From it is called as, what is a sphere we call it as this thing? This is nothing but our ionosphere. So hence the waves which are ionospherically scattered or ionospherically reflected waves. So these two consideration we can look into it whenever we discuss about our sky waves. The region in the atmosphere around 15 kilometers. Suppose we are seeing we will be having one earth is there. Near to the earth, suppose this is our earth surface. Near to that one we will be having different layers. So nearer what we are saying in the distance of 15 kilometer. this 15 kilometer above the surface of the earth is called as what? Biosphere is there. The wave which are reflecting or scattering in this biosphere in this region before reaching to the receiving antenna. Suppose you will be having one receiving antenna over here. Before reaching to this end, before reaching to this point, the wave which we are getting, that is nothing but tropospheric waves, or the wave which we are taking part into this to consideration, then we can say it is a earth and this end. Then we have troposphere. That troposphere will be there, then it is considered to be the tropospheric waves. Next thing is that what are the factors that our wave is going to propagate. So for getting this factor, we should have to first differentiate what are the types of waves we are using and where it is going to be useful. So as you can see over here, we'll be having different modes of propagation over this end. So as we are seeing the frequency, first thing is that 300 megahertz, then 30 megahertz, then 3 megahertz, then 30 kilohertz. From this end we are reaching to the highest one. So when we are saying it is a 30 kilohertz, the wave which we are getting is called ground wave propagation. As it is reaching from this end to next is 3 megahertz. That is a range between ground wave propagation. So then next is what is the range of next part? We can say it is 3 megahertz to 30 megahertz. Then we can say it is a sky wave propagation. So like that, 30 megahertz to 300 megahertz, then it is space wave propagation. So where it is useful? One, it is for microwave band. Next is what? Point to point communication. Next is used for television transmission and FM transmission. The frequency modulation and the TV transmission, that can be done by using the space wave propagation. So now we are discussing about our ground wave propagation. So what is a factor, how the distance can be obtained. For that factor we are going to see. So we are always want to see from the earth surface. So what is the distance we can get? A distance is an important factor where maximum range of the ground wave propagation not only depends on the frequency but also the power of the transmitter. So that can be depends as D is equals to 50 by F in, that is a frequency in megahertz. We are measuring the frequency in megahertz, whole the power of 1 by 3 in miles. So this is the frequency of ground wave propagation, which depends upon frequency as well as the power of the transmitter. So for that purpose we have to use this distance relation to find out the frequency and the distance of your ground wave propagation. So this is, we can use it where the 50 is a constant value. So we are measuring the distance in miles. Next concept we are going to discuss about radio horizon, that is nothing but line of sight. So what is the meaning of LOS? LOS stands for the line of sight. It is called as radio horizon, the locus of the point at a distance which the direct rate. Suppose you will be having the ray, suppose you are considering one receiving antenna. So suppose you had one receiving antenna, this is going to receive the whatever the transmitting antenna has been sent. So this is, you had receiving antenna. So what we are going to see? We are going to see one radio wave. Suppose what you had, from one end you will be having the transmitting height HT and one end you will be having receiving height HR. You want to find out the distance of this, how the wave is going to travel from the transmitter to the receiver. So you want to find out this radio. So what do you want to find? Since it is passing the radio wave frequency, so we just want to find out radio wave between these two. So what we can say for this end, this is called as optical ray. So when we want to see the optical ray from this end, we are considering one more point over there where HT stands for the transmitting antenna height and HR stands for the receiving antenna height. So we want to find out the both transmitting and receiving antenna. From that we are considering one point O. From this, it is point O is there, which is both are contained from the height of the transmitter as well as from the height of the receiver. It is at equidistance. Suppose the distance over there is R. So you want to find out what is a radio horizon. So what is the radio horizon? In the sense, we want to find out between this end, between these two ends, how the wave is going to be traveled. So we want to find out these two conditions, what we can say for that? We can say that the locus of this point O at a distance which is directed between the rays between two tangent to the surface. This we are drawing two tangent point to the surface. Then we can say it is a radio horizon. So which is observed circularly on a spherical surface. So we can see the complete spherical surface. We measure this part. Then what we can say for that? The maximum distance between these two antennas along the surface, suppose it's the earth surface, from the transmitter just touching the surface of the earth. So what is the optical point we are saying? Suppose you had this part, that is the optical ray or optical horizon, the maximum distance between the two antennas, that is transmitter and the receiver of the earth, such that the ray from the transmitter just touches the surface of the earth is called as optical ray. So that's point we are going to derive it, how this height of both of them is going to be obtained. As you can see over here, we will be considering one earth surface. Over there we will be having the transmitter HT and we will be having the receiver of height HR. So what is the effect of bending of radio wave which traveling through atmosphere can be taken into account? This part we can take into account by assigning a greater radius to be the earth, from the earth, and it actually has the radio wave which is taken from to a travel in the straight path. So we are considering one straight path from the point of the earth. From this one we want to find out the maximum diameter of D max. We want to get it. For getting this thing, what we are considering? We are considering one end, the transmitter of having height HT with a distance of D1. So like that we will be having the receiver height HR. From that we have one more distance D2. So we want to find out the point from where it is going to get it. So for that, standard atmospheric condition, what is there? That can be obtained by considering R dash. So what is R dash? Is equals to 4 by 3 times of R. What is R dash? That is the radius of the earth from standard atmospheric condition. What is R dash? We can say it is nothing but the R dash. What is R dash is all about? It's all about the radius of your atmospheric, which is a standard one, whereas this R is nothing but the actual radius of the earth. So we have to consider atmospheric radius as well as the radius of the earth. Next condition is that we want to find out the relation from these two ends. That means what you want to write, you can write as, suppose I want to consider one triangle over there. This is the point we are considering height of this HT and the radius of this complete thing is what? R. So we want to get the first condition. What we can write? If you see the one triangle, what we can write? If you want to find out adjacent and the opposite, these two are adjacent, opposite, this is your hypotenuse end. So what we can write? We can make one triangle like this. So what is the adjacent value we can write over there? This is having some D1. So what is the distance over there that I can write as R dash? So R dash you want to write because it's a radius from the point of geographical atmospheric standard. So from there, what is this end from the transmitter? R dash as well as the height of the transmitter RT. Similarly, like that, if you want to make one more triangle, we can get it like this. So similarly, what is the value from this end? We can write R dash plus height of the receiver. So this end is what? Same, exactly same as the atmospheric standard radius R dash. Over there we can write this is D2. So by considering these two triangles, we can find out two relations. What are the two relations we can get? We can get the Pythagoras theorem. We can find out the hypotenuse end, that is R dash plus HT whole square can be written as D1, that is the distance of that opposite square plus adjacent square is R dash square. Similarly, from the receiving end, what we can write? We can write as R dash plus HR whole square, that is hypotenuse square is equals to opposite square, that is D2 square plus your atmospheric radius adjacent square we can write. So out of these two, suppose I am considering this end. This is your equation 1 and that is your equation 2. So from these two equations, we are considering the equation 1 and we can write over there, if you want to find out D dash or D1 of that, distance from the transmitter should be equals to, shift this on right side, it will be minus. So we can write over there as R dash plus HT whole square minus R dash square. So here we can apply A plus B whole square, we can apply to this terminal. So we can write as this is as it is. D1 square is equals to a plus b whole square. We can apply to this term. We can write a square plus b square plus 2ab. We can write, and the beside one is what? R dash square is as it is. So we can cancel this plus term and this minus term, and we can shift this term is over there. We can write over here is d1 whole square is equals to, we left with ht of t whole square plus 2 times of your r dash into ht of t. We can write this is our left out expression. So we got it, d1 square is equals to ht square plus 2 times of your r dash into ht of t. So now what is the condition we are considering? We are considering that suppose your atmospheric radius r dash is much greater than your height of the transmitter. Then we can write hence the r dash of ht is much greater than ht square. That means what term we can neglect? We can neglect ht square because it's a very less term. So we can write over there d1 square is equals to, the first one is neglected, so with 2 times of r dash into ht. So square shift on right side, we can get d1. So d1 should be written as 2 times of your r1 into ht with root. So this is the first distance we obtained for our expression. So d1 we got it as 2 times of root 2 into r dash into ht, whereas r dash is your atmospheric radius, ht is the height of the transmitter. So similarly we can find out d2 as well. So d2 we can write as under root of the same thing. We can get by considering Pythagoras theorem, everything we can do it. We can write instead of the transmitter, we get over here is the receiver h of r. This is similarly. So, or else you can go for the complete derivation part. So we got d1 as well as d2. So maximum radio range, that is radio of that range, we can find d max. We can get as which, how can you get d max? We want to obtain d max over there. So what can we write? D max is equals to your height of the transmitter from that distance d1 and the distance d2. You can consider both the distance d1 and d2. We can obtain the d max. So we want to find out the maximum d max value, that is the maximum distance from the both transmitter and receiver, that can be written as d max is equals to d1 plus d2. What is d1? We got 2 r dash ht, d2 we got 2 r dash hr. So both the values we had, we can substitute both the values. And what is r dash? R dash is nothing but radius of the atmospheric. So that is r dash, which is a standard one, 4 by 3 times of r. So what is 4 multiply with this 4 2s are 8 by 3 r ht, plus for this also we can write 8 by 3 r h of r. So that two values we can substitute, we got the d max. And what else we know? And what else we know? We know that your radius, what is radius? We can add radius from the our antenna from the atmosphere, that is the radius of the earth. How can you get the radius of the earth? What is there? 6370 kilometer. So this we can substitute. If I substitute this thing in the given condition 1 and condition 2, we can write as, so your d max should be written as the same 8 by 3 as it is your radius. What is the radius we got now? 6370 kilometer. What is the kilometer? Means 10 power 3 into your height of the transmitter ht, plus same thing we can write root of 8 by 3 into 6370 into 10 power 3 into height of the receiver hr. So we got both the values, we can get it. So we can write your 10 power 3 and this 0 will be 10 power 4. So this is 10 power 4. We can write without root by considering the same into outside the root. We can write as d max is equals to 10 power 3 and 10 power 1 is 10 power 4. Outside the root I can write as 10 power 2. So into this, what is left out term? 8 by 3 into 6.37 into 10 power, again I can write as 1 more 2 because I am writing point over there, plus under root of 8 by 3 into 6.37 into 10 power 2 into height of the receiver hr and height of the transmitter ht. So by doing this we can write out of this 2 points also are one side outside, so we can write 10 power 3 into what is left out over there inside the root now, under root of 6.37 into ht plus root of 6.37 into hr by 3. Here also by 3, and we had 8 into, and here also we had 8 into. So we are taking radius. Once again I am explaining you. Radius we had, radius of the earth is 6370 kilometer. These are the two conditions. We got d max, d1 plus d2. d1 is height of the transmitter and d2 is the height of the receiver. So we got radius over there 6370 into 10 power 3. Here also 6370 into 10 power 3. So we are taking, after we are putting the point here, 10 power 3 will become now 10 power 6, because 1, 2, 3. After 3 decimal, we are writing the point. So we can write 10 power 6 here, 10 power 6 here. Out of these two, 10 power 6, if you are writing the root, this value outside the root, it will become 10 power 3. 8 by 3 into 6.37, 8 by 3 into 6.37. What is 10 power 3? It is 1 kilometer. So we are writing d max in kilometer. 8 by 3 of this root is nothing but, without root, 4.12 into what is left is inside the root, your transmitter height plus your receiver height. So we can write your total d max. So d max can be written as 4.12 times of root of the height of the transmitter plus root of the height of the receiver. So this is the line of sight distance expression in terms of kilometer. So this is about our line of sight of radio. We got it. So thank you for listening to my video, and the next session we are going to discuss about the propagation method. Stay at home and stay safe and try to practice this derivation.